Hello students, today we are going to study about finding the limits graphically, but before you dive into the video, I would just request you to subscribe my channel so that you can get the notification whenever I upload the new mathematical topic in the videos. Okay, so as we said that our success criteria is to analyze the graph and evaluate the limits at specific point and give reasons that why the limit fails to exist. So before we start, it is very important that we should know how to read the graph. So as you already have studied in the previous classes that if I ask you to read the graph at certain point A, then you look at the graph and you will just try to find that when x equals to A, where is that included point, and you read that included point and that would be your answer. So let's suppose if here I just make a graph, for example in graph number A, if I ask you to read what is f of 1 equals to. So what do you do? Basically on the one you look at the point 1, means the x coordinate 1, and you go up and you see that where is this point lying, and you read the y value. So you can say that f of 1 equals to 2. Similarly, if I ask you here, for example, on the same points, let's take this is the point, okay, and this is the graph, and just have a look at graph number B. And now tell me what in graph number B, what is f of 1 equals to? Okay, so what you will do, you will go to the 1, okay, and you will read where is that included point, shaded point, and you read the y value, that is equals to 3, and that is your answer. Now let's take one more example to understand the concept more. So let's have a look at graph number C. Now in this graph, if I say that find out where is f of 1, what is f of 1? So what you do, you look at the x coordinate and then you go up, and what have you observed? That there is a hole in the graph. It means there is no included point or there is no shaded point. So what do you say? That at 1 the function is undefined. So that is your answer. So it means that you read the point, you read basically the included point or the shaded point in the graphs, and if there is a hole, you say that the function is undefined at that point. Now have a look on graph number A and B and check your results and tell me that what have you observed. Now you have observed that there is an included point or there is a shaded point, means you have to point out on a shaded point whether it is connected with the lines or it is separately sketched. So it means no matter that included point is attached with a line or not attached with a line, you just read the shaded point at that specific x value, and that is your answer. So this is the way we read the functions at certain point. Now let's move further. So here we are going to study about estimating the limits graphically. So whenever we talk about limits, studying the limits graphically, remember that limits can be shown on the graph with the help of lines. Means previously we have studied that the function at a specific point can be seen or can be shown with the included point, no matter it is attached with a line or not attached with a line. But in estimating the limits graphically, you have to look the lines. And if only the point is given, then we are not able to study, or we are not able to read the limits. Now, what is meant by limit? We already have studied that if we say that limit x approaches to 2, for example, for a function f of x, what does it mean? We already have studied how do we write the limits, okay, in this notation. So if you don't know how to write, then you just check my previous videos. Okay, now limit x approaches to 2 for this function. What does it mean? That when the limit is approaching to the 2, yani it is not exactly at 2, but it is coming from the left and coming near and near from the left, or coming from the right hand side. It's not exactly at 2, maybe it is at 1.999, or it would be at 2.00001. Okay, so they are very near to the 2, means the approximately they are equals to the 2, but they are not exactly 2. Now the limits reach from the left side, and also they come from the right side. When they are coming from the left side, okay, so we write on the 2, on the top of the 2, a small negative sign that shows that the limit x approaches to 2 from the left hand side. And now if the line is coming from the right hand side, then on the 2 we write a small plus, which means that limit when x approaches to 2 from the right hand side. Okay, now let's understand that how can we read about the limit. Previously we have seen that what was f of 1 equals to. Now in the same thing we will see that how can we read limit x approaches to 1, f of x. Now understand that if some line is coming from the left side, look at my line how I am sketching, and it reached to certain point, it means that you are coming from the left hand side and you are reading this line from the left hand side. And now there is also one line coming from the right hand side and stopping at this point. Now if I ask you to read the limit x approaches to 1 f of x, now what is the main thing you have to focus? That on the 1 there is no plus or minus written, means above the 1 as a power there is no plus and minus 1 written. It means you have to see that whether the two lines coming from the left and the coming from the right, are they connecting at the same point or no. So look at this one, go up and read the y value. What is the y value over here? It is 2. And what is the important thing? That the left line and the right line are approaching and they have the same height. So you can say that y value is the limit value when x is approaching towards the 1. Now what is another thing? You have noticed that there is a hole over here. So no matter there is a hole or there is a solid point, we will read and we will write the same answer. Now for example, now let's see over here. Now that was the point previously I made in second graph, and I ask you read the limit at x approaches to 1. Now, have you seen a line coming from the left side or coming from the right side? No, you can't see any line on the graph. It means you can't read the limit. Why? Because there is a point exactly at 1. There is nothing on 0.999 or there is nothing at 1.0001. Okay, so it is exactly at 1, so there is no limit over here. Now, if we see that there is a point and there are the lines like this. Now, what have you seen? That there is a line which is coming from the left side and this is the point, okay, at 1. And there is also a line coming from the right side, and there both the heights are same, that is equals to 3. So we can say that limit x approaches to 1, f of x equals to 3, because they both the lines, they are connecting with a solid point now, but their height is exactly same. So whether the line is whether there is a hollow point or there is a shaded point, if they are connected with the lines, it means that the limit exists. Now have a look over here. Now let's see on the same one. Okay, and you see that I am trying to make an asymptote, for example like this, and for example like this. Okay, so this is the graph. Now, what have you seen? That there is a line which is coming from the left side. Now, again, we have the same task. It means that read the limit at when x approaches to 1. Now, what have you observed? That there is an asymptote at 1. There is a line coming from the left side, and the end behavior of that line is that it is increasing and increasing and increasing. When it will stop, we don't know. Similarly, there is a line which is coming from the right hand side, and it is decreasing and decreasing, and when it is stopping, we don't know. It is decreasing without the point, and they are not meeting at 1. So in such cases, whenever you see any vertical asymptote, you will say that limit does not exist. So I hope that this concept is understood to you. So the first thing, in order to read the limits, it is important that the points are connected or are shown with the help of the lines. If there is no line, only a point, it means we cannot read the limits. Now let's talk about one-sided limit. What are one-sided limit? One-sided limits are the limits which are shown from one side, either from the left side or from the right hand side. Now again, the limits can be shown with the help of the line. So if the line is coming from the left side, now let's see about this one. If the line is coming from the left side and is stopping at that point, for example A, and this is L. Okay, so the line is coming from the left side. So if I ask you to read that limit, so you will write limit x approaches to A, left side. For the left side, we write a small minus on the top of that x value and f of x. So you look at the left line and you read the y value, that is equals to L. Similarly, if I ask you that there is a line coming towards the A, and here the point is S. So you can say that limit x approaches to A from the right hand side is equals to S. Now for the right hand side, we write a positive sign. So the one-sided limit can be shown, right-sided limit with a positive sign on the top, and left-sided limit with a negative sign on the top are shown. Now look at the graph one more time and see again what I said, that if the two lines, the A and yani left and the right side, and their extended height is, they are reaching to the same height, then you can say, now here if I say that what is limit x approaches to A is equal to, you will say L. The reason is that the left side and the right side limits are same. But if the height of the left line at A and the right line at A are not same, now here one is L and one is S. So you can see that now if you see limit x approaches to A from the left side, what is it equals to? So from the left side, this line you will read, right? This line. What is this equals to? This is equals to L. Now limit x approaches to A from the right side, what is it equals to? So if we read this line, this is equals to S. Now, the left side and the right side, their heights are not same. So, in such cases, when we read the limit from the both side, we will say that it does not exist. And why the limit fails to exist? Because the right hand side limit is not equals to left hand side limit. So again revise the concept that if there is a line which is coming from the right side, it means for example it is coming from the right side, okay, whether it is connected with a hollow point or it is connected with a shaded point, you will see that what is the limit x approaches to 2 from the right hand side. If they ask you to read this thing, then you will go to the 2 and you will see that what is the y value over here. So the y value is also equals to 2. But what have you focused? You have focused on this line only, which is coming towards the 2 from the right hand side. Limits from the left hand side. Now for the limit from the left hand side, it is very important that you, if there is a, for example, this point and connect it with a line, so you will focus only at 2. Where is the line coming? The line is coming from the left hand side, and what is the height of that line? It is 1. So we will write limit x approaches to 2. From the left hand side we put a negative on the top of the 2 and it is equals to 1. So we look at the x value but we read the y value, and for the limits it is important that it should be connected with a line. Now let's see and let's check an answer. Now they are saying read the limit when x approaches to 3. This negative shows that from the left hand side. So you look here, you read the 3 and you see there is a line coming from the left hand side. And what is the y value when it reached to the 3? It is equals to 0. So the answer is 0. Now have a look at some of the graphs having the unbounded behavior, means asymptotes at the particular point. Now read. Limit x approaches to a from the left hand side. Look at the graph. Now there is a line coming towards the a, and what's happening? It is not reaching exactly at a. What is happening? That it is increasing and increasing and increasing without the bound. When it will stop, you don't know about the particular point, since it is increasing and the end behavior is that it is positive infinity. When it will stop, we don't know, so our answer is positive infinity. Similarly, if we say that limit x approaches to a from the right hand side. Now in this case what you see, that there is a line coming towards the a, and what is happening over here? It is also increasing and increasing without the bound. So you will say that limit x approaches to a from the right hand side is equals to positive infinity. Now look at the graph, next graph. So limit x approaches to a from the left hand side. What is happening? That the limit is that the graph is decreasing without the bound. So you will write negative infinity. Similarly, in the fourth graph, the line coming from the right hand side towards the a, there is an asymptote at a, but the line is decreasing and decreasing without the bound. So you will say it is equals to negative infinity. So this is the way that if we have an asymptote on certain point, then we look at the end behavior. If the graph is increasing, we will say positive infinity. If it is decreasing, we will say negative infinity. Okay, so let's have a look at the graph and try to solve it. Now here the first part is limit x approaches to 0. No plus minus is written. It means just see the line joining from the left and from the right, and they have to be exactly on same point. So this is the 0. So what is this point equals to? This is equals to also 0. And now just for your confirmation that there is a line coming towards the 0 from the left hand side, and there is a line coming towards the 0 from the right hand side, and both are meeting at 0. So that's why you wrote 0. Now the next thing is limit x approaches to 2 from the left hand side. Now look at the 2. Where is the 2? This is the 2. Left hand side line you will read. Okay, so there is a line which is coming from the 2. Now look at this one. I will tell you that here is the 2. Okay, so forget everything. Just read this point. Okay, and if they are saying that there is a line coming from the left, so see only this side, means see only that line. So on the 2 there is a point over here which is connected, and their line is coming from here. So that is the line which is coming towards the 2 from the left side. And what is this equals to? This is equals to 1. Now read the limit x approaches to 2 from the right side. Now again you focus on the 2. Now this line was coming towards the 2 from the left side. Now see where is the line coming from to the 2 from the right side. So this is the line. Okay, so this is the line. Where it is line, where the line is going or increasing up and up and up. So this is equals to positive infinity. Forget about the other lines because the same line is extended and going towards the 3. So you don't read the 3 thing. You only see what is happening on this area, in this area. Now 3 from the left side. Look at this. Now 3 from the left side means you will focus on this area. There is a line coming towards the 3 from the left hand side. What is happening? This line is decreasing without bound. So it means it is going to be negative infinity. So we have to focus only on the area which is coming towards that side. So try to understand this more. Limit x approaches to 0 from the left hand side. So look at this. 0 is where? Look at the 0 here, x value. And now you will focus only on this area. How you will focus? Let's check how you will focus. Left side. Okay, left side means this line is coming towards the 0. What is the y value? The y value is 3. Now right side. Okay, so now right side. So it means on the 0, the coming from the right side, this line, right? Again, the y value is 3. Now look at this. Limit x approaches to 0 from both sides because there is no plus and minus written in the C part. What does it mean? It means that both the lines coming and meeting at the same point? Yes, you can see there is a green arrow and I have made a red arrow, and both the heights are same. And what is that point? It is equals to also 3. Now what is g of 0? G of 0 means you have to read the function specifically at 0 and make sure that the point is shaded. Of course there is a line, so of course this point is shaded. So this point is shaded, which is also equals to 3. So this is how we read the graphs. Have a look over here. Now again there is a graph, 0 from the left side. So you will read only this area. Okay, left side means there is a line coming towards the 0 from the left. So what is it equals to? 0. Now right side means there is a line coming towards the 0 from the right side. Again this is also equals to 0. If both are on the same height, so from both sides the answer is 0. And since it is all a one line, it means the point is shaded. So g of 0 is also equals to 0. Now look at this graph. Limit x approaches to 3 from the left side, from the right side, from both sides, and the function is specifically at 3. So where we will read, this is 1, this is 2, and this is 3. So we will look at this area now. Only at the 3, only this area. Now have a look. Limit from the 3 from the left side. So which line is coming from the left side towards the 3? This line, right? This line is coming from the left hand side. And what is the y value at this point? This is -1. So the answer is -1. Now limit x approaches to 3 from the right hand side. So which line is coming towards the 3? This line is coming. So what is this point equals to? The y value is equals to 3. Now, are both the lines coming from the left and the right meeting with each other? No. And you can see from here, one is -1 and one is 3. So the answer is limit does not exist. Now, for f of 3, no matter there is a line or not a line, you have to read where is my shaded point. So on this specific 3, where is the shaded point? Here is the shaded point. So what is the value of this one? This is equals to 1. Let's see that do you understand these graphs or no? Limit x approaches to 2 from both sides. So this is the 2. Where is the point? Here is the point. The answer is -1. Now second graph, limit x approaches to 3, g of x. So on the 3, for the limit, we have to read the line. So ignore the point, read where is the line, here is the line, this is specific point. There is a line coming from the left, there is a line coming from the right, both are meeting at the same point, the y value is 4. Although the point is hollow, but we will read the answer. Now limit x approaches to -2. So -2, for -2 you will focus this area only. What have you seen? That there is a line coming from the left and the value is -5. There is line coming from the right and the value is -3. The lines are not joining. So of course the answer is that limit does not exist. Now the reason why the limit does not exist, because the limit from the left hand side at -2 is not equals to the limit x approaches to -2 from the right hand side. So this is the way we have to represent our mathematically, we will represent our reason mathematically. Now look at the graph. Here the graph, you have to read the graph, the limits and specific point at 3. So you have to focus this area. Sorry, I have made it wrong. So you have to focus only this area. So when there is a line coming from the left side towards the 3, it is going down and down and down. You can see unbounded behavior. So you will say it is equals to -infinity. Similarly, the line coming from the right hand side also going down and down because of the vertical asymptote. It is also -infinity. Now look at that. What is happening when limit x approaches to 3 from the both side? Now understand that when the left side line will stop or the right side limit it stops, we don't know. So you can write that the limit does not exist at 3. But in some of the books, the answer is -infinity. The reason is that they says that of course the limit x approaches to 3 is not exactly the same, means we don't know the exact point, but both the limit from at the 3 is diverges and it is diverging and decreasing without the bound. So you can say that it is -infinity because both the limits diverging from the left and the right are -infinity. So their path is same. It means they both are decreasing without the bound. So you can say that the limit x approaches to 3 is diverging to the negative infinity. But both the answers will be taken as the correct answer. Now what is f of 3 equals to? So you will see the point only the point which is shaded. So you will read that this is equals to